All right, Chem 1, I've got a couple of videos here to chop up Chapter 5 for us. You'll notice I'm starting on this screen labeled Section 2. Section 1 will be what we covered in class at the beginning of last week on that Monday when we introduced Chapter 5 prior to taking your second exam. And again, if you wanted those Exam 2's returned to you, they are on a desk outside of my office, though I'm not sure when you'll be able to get into the building next time. So what we covered thus far in Chapter 5 was all of 5.1, the basics of energy, things like heat and work, endothermic, exothermic, etc. And we made our way through most of 5.2, like 90% of calorimetry, which is great because those types of problems, Q equals MC delta T, are a huge part of Chapter 5. Okay, so I'll have a short video here to wrap up 5.2, and then I'll cut up 5.3, that discussion of enthalpy, into 2 other videos. Okay, but first I wanted to pick up with the problem that we had left off with at the end of that lecture where we started Chapter 5. And this was a discussion about the heat of a reaction. Okay, and we had solved for the heat of the solution, right? The fact that it was an exothermic reaction, so the solution increased in temperature. Okay, we got a final answer of 2.9 times 10 to the third joules. But if you were to be reporting this final answer on a quiz, jumping to the next slide here, keep in mind that Q of the solution, which is what we did the calculation for, is equal to negative Q of the reaction. They've got the inverse shown on the slide here. And that's just going back to that original relationship that we discussed, right? System and surroundings. They have the same numerical value, but opposite signs. So in this situation, which these 2 slides are showing us, yeah, I've got them as slide 45 and 46, they must be a duplicate in there. That just tells us that, right, the Q of the solution was 2.9 times 10 to the third joules. So Q of the reaction must just be negative of that number. So negative 2.9 times 10 to the third joules, or, right, if we think about that a different way, a negative Q value tells us that this must be an exothermic reaction. Okay? It's releasing heat. And those things that we covered in that Monday class in that problem right there are great practice for using Q equals MC delta T, which is a key idea from this chapter. Make sure prior to jumping onto the Chapter 5 quiz that'll come at the end of this chapter, you know how to do those types of calculations. A couple other quick ideas to wrap up the ideas of calorimetry. Okay, these are just conceptual things so that you are aware that they exist. Okay, any assessment won't cover bomb or whole body calorimeters that are shown next. Okay, a bomb calorimeter is kind of a more exciting name, right? It's a more rigorous calorimeter where you can actually measure the heat released by things exploding, right? Hence the word bomb in the name. But what the bomb actually refers to is the container that holds the reactant. It's just for strongly exothermic reactions. Okay, and if you look on the slides that are next here, okay, you can see kind of a rough sketch here. You see bomb labeled there on the right-hand side. It's just a strong steel container surrounded by water, and you still measure the temperature change of that water with the solutions and then relate it to the system. Other things that exist are whole body calorimeters, and these things are really neat because I'll jump to the next slide here and then come back. Right, this is a calorimeter that's actually designed to fit a human body. And this is where we can get information related to nutritional values, right? Because if we have that closed system where a human being can live in there, like a tiny cramped hotel room, right? Because it does have to be closed off from the atmosphere, we can get information about respiration relating to different people, different environmental conditions, different diets, okay, the effect of health conditions. But like I said, there's only a couple of these in the world at, maybe a dozen or 2 at research institutions. But we discussed the idea of a nutritional calorie with the capital C at the beginning of Chapter 5, and that's where that type of information comes from, right? Everything you see on a nutrition fact. So I've got here an example test question, and with these videos, it's difficult to show that. So I'm going to upload a separate video showing that calculation, right? Just drawing it out on the document camera. So if you have any questions about 5.1 and 5.2 or that calculation, post them on Blackboard under the Chapter 5 discussion, email me, we'll connect via Zoom, anything to get those questions answered. But make sure you're comfortable with those Q equals MC delta T questions.